All right. Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right. So a warm-up 113 is on the screen. Let's get started, please. Today we're moving on. We're adding more. Well, we're adding a couple more things to what we did last week with our rational functions. But today we're going to be looking at it through the scope of transformations. So everybody's ready, of course, because everybody did their home plate last week. Very good. All right. Also, reminder, is this being recorded? Yes. In a little bit, make sure you go to Canvas, go to our class, go to grades, take a screenshot, bring that sign tomorrow, just to make sure that we are on our way expeditiously through this quarter. And if you notice, time's flying by. We're almost done with April. Let's go. April's almost gone. And also, shout out to all of you that were at the game. I saw some of you getting there with your BFFs and enjoying the afternoon. Imagine that they gave me a mic every day. I'll be dangerous out there, right? My goodness. Let's go, Jesus. All right. I'll give you guys some time. Copy it. All right, let's get the show on the road. Oh, my goodness. F of x equals 2 to the x. We got f of 1, 2 to the x. Instead of x, we write 1. So this is 2. And f of 2, 2 to the second. Thank you. 2 to the second is 4. And f of 3 is 2 to the third. 2 to the third is 8. So far, so good? Yes? Yes, Mr. Q. Let's go to f of x base 10. So now we got 1. That is f of 1. Oh, let me just write it to the side so I can say space. That is 10 to the negative 1, which turns into 1 over 10 to the positive 1. Next one, f of 2 equals 10, 2 minus 2. That's 10 to the 0, which is 1. And last one, f of 3 equals 10, 3 minus 2. That's 10 to the first, or just 10. Number 2, we have a cubic. We're at 0, 0 there. And according to this transformation, we are flipping it and then moving it 6 to the right and 2 up. 6 to the right, 2 up. So we end up with a flipped cubic up here. Number 3, this is 1 over a cubed. This is 1. And this is distribute. That is 1 to the negative 3 over x to the negative 3 becomes x to the third over 1 to the third, which is x to the third. And last but not least, 2 to the x. 2 to the x times 2 to the negative 6. 2 to the x stays there. 2 to the negative 6 goes to the denominator, turns into a positive. So this is 2 to the x over 2 times 2 times 2 times 2 times 2 times 2. So that is 8 times 8, that's 64. And if you got that by yourself, all right, make sure you send that in, please. Copy the agenda. Warm up 113, rational functions. In parentheses, I wrote transformations. And tonight you're going to have 6 of them, 6 transformations. To access the home plate, here is the code, PGFV5. PGFV5. V 5. Sure you write that down, please. And your home plate is going to look like this. 6 transformations. They should look familiar, but today we're going to walk through those just to make sure we see all the components. Okay? All right, get a Cornell note ready, please. All right, here we go. I can transform rational functions. I can transform rational functions. What are rational functions in your own words? Tell your neighbor, please. What are rational functions in your own words? Looks like Enrique's got it. Very good, Enrique. He's so focused. All right. Type it on your screen, please. Rational functions in your own words. What are they? What are rational functions? Or a happy face? What? Some of you are right. Sketching a happy face. All right. Thank you. Some of you are giving me the definition from your notes. I want it in your own words. Some of you wrote an equation with a fraction. Good. So, yeah, an equation that has a fraction, and those fractions should have polynomials, yes? All right. So we know what they are, what they look like. We've been working with these already. We have steps to graph and steps to write. And then we said we were going from the general rule to the now rational function rule, yes? And we said that the parameters do the same thing. Is that correct? Is that correct? Yes. So, let me pause the music in the back, look up. So if I was to cover this one and just focused on this one, tell your neighbor what K does to the entire graph of the rational function. What does it do to the entire function? Caesar, what does it do to the entire function? Up and down, that is correct. You're like, but isn't that an asymptote also, Mr. Q? Yes, it is. But in transformations, it does the same thing. So therefore, what does H do? Remind your neighbor, what does H do to the entire rational functions graph? The entire graph, what does it do? Let's go with Mariah. Side to side, that is correct. Now, look up. What if A in the function was a negative? What would that do to the graph? Tell your neighbor. What would that do to the graph? Mariah, pass them one. Mario, what does that do to the graph? It flips it, yes. So if it's down here, it just goes up and the other one goes down. However, what did we learn last week? If A was a number, such as that, the point is one step to the left and how many down? 3. And one step to the right, how many up? 3, and so on and so forth. Why? Because it stretches. What if this was a fraction, though? Tell your neighbor what would happen if it was a fraction. Instead of stretch, it compresses. That is correct. The step would be a little bit closer, the points. And B does it the same way, but it does it horizontally. It stretches or compresses horizontally. This one does it vertically. Okay? So that's where we're headed today. So we know what vertical asymptote is and what a horizontal asymptote is. All right? Copy this one onto your notes, please. Example number 1. Example number 1. Let me send that to your screen. And it reads, transform the parent function f of x equals 1 over x, given g of x equals 1 over x plus 2 minus 3. Copy that, please. Give some time, and then set up a coordinate plane on the side from -8 to 8 on both domain and range. I'll give you some time. Be neat, please, so at least you have a good one to look at in your notes. So it says, transform the parent function f of x equals 1 over x. First things first, we need to graph the parent function with its VA and its HA. So, for this one, tell your neighbor what the VA is. X equals what? And the HA. HA f of x equals what? All right? Tell your neighbor what the VA is and the HA for this one first. Right now we're focusing on the parent function. All right, it looks like Monza's got it. Very good, Monza. Marin got it. I see you. So let's go with Gabriel. What is the VA? 0. And the HA? 0. Okay, so let's do that. So the VA at 0. And the HA at 0. Okay. So now let's graph this parent function without a table. Tell your neighbor where to place the points at, please, for the parent function. From there, where do we place the points to graph our function? Tell your neighbor, please. All right, good conversations. Help us out, Joseph. Where do I place the points? From here, from where both asymptotes intersect, where do I go? One up. What? Okay, from the center where both asymptotes intersect, we always go one to the left and one down. Sketch that side. And again, from where both asymptotes intersect, we go one up and one to the right. You good, Enrique? Okay. Put away those AirPods, please. All right. So, how are we doing up to right there? Are we good? All right. So now what we're going to do, we're going to transform this according to this. So, look at it. And we know that our form has the K at the end and the H next to the X. Is that correct? All right. So, tell your neighbor where we're going to move this entire thing according to that. Tell your neighbor, where are we going to move that to? All right, looks like Enrique's got it. Enrique, where are we moving? Left 2 and down 3. Hands if you agree with that. That is correct. Now check this out. We're going to move everything. The asymptotes, the points, and the graphs. 2 to the left and 3 down. So kind of like this. What's up? 2 to the left and 3 down. You guys see it? Again, here it goes again. 2 to the left, 1, 2, and 1, 2, 3. We should end up right there. So let me put it back over here. So this is what I'm going to do. I'm going to start with my asymptotes. Where they both intersect, I'm going to move it, this point, I'm going to move it 2 to the left and 3 down. 1, 2, 1, 2, 3. So my new asymptotes are, I'm going to make it a little bit thicker, right here. And right here. You guys see what I did? Once again, I moved first the asymptotes. So now, from there, if I'm basing myself now here where both asymptotes intersect, tell your neighbor the coordinates of one of the points and then the coordinates of the other point. Coordinates of one point, coordinates of the other point. All right, Mario. Enlighten us. Give me a coordinate for the point. Help them out, Rachel. Coordinate. -1 and -2. Okay, so that's on the right top. Yes. How about the other one? -3, -4. That is correct. All right. Let's see if we got the process correctly. Step 1, we graph the parent function with its asymptotes at 0. There it is. Second, we graph the transformation starting first with the asymptotes. We move them according to what we see here. And then we plot the points. All right, send me your notes, please, on the screen. All right, how are we doing with this? From 1 to 5, how comfortable are you with this? 5 4s, 5 4s, 3s, 5 5 4. Okay, let's do another one. Bless you. Example number 2, bless you. Again, transform the parent function f of x equals 1 over x, given g of x equals 1 over x minus 5 plus 4. Bless you. Copy that, set up a new coordinate plane. I'll give you guys some time. And do that one by yourself completely. I sent it to your screen. All right, so transform the parent function f of x 1 over x, given g of x equals 1 over x minus 5 plus 4. What is the first thing we do, Dana? The VA, which is x equals 0, and what is our HA? All right, so let's graph those. We got 0, and 0. All right, so now I just need to graph the actual function. Where do I place the points, Dana? From the center, where do I go? This is the gem right here. From the center, I go which direction, Dana? Enrique looks like he wants to help you. All right, Enrique, where do I go? What? What? One to the left and one down, okay. And then go back to the center and then right and up, one, okay. Woo! All right. From there, we need to transform it according to this. So here we're going to move everything according to that. Where are we moving everything? All right, Denise, where are we moving everything? 5 to the right and 4 up. All right, so I'm going to start with my asymptotes. So where do they intersect? Right here. I'm going to move that 5 to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4 up. So now my asymptotes are right here and here. Yes? So now we just need to move the graphs with the asymptotes. So give me 2 points. Tell your neighbor the 2 points that you're going to graph now for the new transformation. Give those coordinates. Denise, pass them on. Gabriel. 4, 3. And 6, 5. Let's double check to see if he's right. So from the center, we go 1 to the left, 1 down, 1 to the right, 1 up. Yes, there they are. From 1 to 5, I'll come to party with this. We got it, right? All right, send me your notes, please. Now we're going to number 3. Number 3. This one has a little bit of a curveball towards the end. Let's see if you guys catch it. All right? So, write that down. Example number 3, transform the parent function f of x equals 1 over x, given g of x equals negative 1 over x plus 6 minus 4. All right? So, write that down. Set up a new coordinate plane on the side. I'll give you guys some time, and I'll send this to your screen. All right, so let's go with Mayrim. What do we do first? The VA and HA of the parent function. And what are they? They're both zeros. Okay, so then we got the VA at 0, 0. And the HA at 0 as well. All right, and then to graph the actual graph, where do I go from the center of the VA and the HA? 1 down, 1 to the left. And again, 1 up, 1 to the right. Okay. So far, so good. Next, where are we going to move the whole thing to according to this? Pass someone, Mighty. Gabriel, where are we going to move the whole thing? 6 to the left and 4 down. Okay, 6 to the left and 4 down. So I'm going to take where both intersect here, 6 to the left, 4 down. So now my asymptotes are here and here. Hands, have you got that so far? Okay. Next, If I was to place 2 points for my graph, where would I go from here, from the center, Joseph? We always go up 1 and 1 to the, okay, and the other one? Down and to the left. However, what was a curve by, everyone? What does that do to those points, the last points? They do what? They flip. Therefore, instead of being 1 to the left and 1 down, I should have done what? 1 to the left and 1 up. And this one, 1 to the right and 1 down. Hands if you got that by yourself. Yes? Okay. All right, send me your notes, please. So far, from 1 to 5, how comfortable are you with these? 1 to 5, 4, 5, 4, 5, okay. All right, not bad, not bad. Copy this one, example number 4. It reads once again, transform the parent function f of x equals 1 over x given g of x equals 3 times 1 over x minus 2 minus 5. This one also has a little slider at the end. Let's see if you catch it. Once again, get a new coordinate plane going from -8 to 8. Make it neat. I'll give you guys some time. Go. All right, here we go. For the sake of time, I already sketched the parent function. Here it is at 0, 0 with 1 to the left, 1 down, 1 to the right, 1 up. Yes, there they are. All right, help me finish this off. Where am I going to move that to? Franco, where are we moving it to? 2 to the right and 5 down. Hands, have you got that? Yes, so I'm going to start at the center. I'm going to move first my asymptotes. 2 to the right, 5 down. So my new asymptotes are down here for the vertical and the horizontal. All right, so if I was to go with the original points would be 1 to the left and 1 down, 1 to the right and 1 up. However, what does this tell us to do? Yes? Kelly, tell us. Instead of going 1 to the left, I go 1 to the left and 3 down. 1, 2, 3. And 1 to the right, 3 up. 1, 2, 3. Thank you. Hands, if you got something? Thank you. What was that? It was like a cough sneeze. Did that happen to you guys? All right. Hands if you got that by yourself. Some of us, yes. Okay. So once again, remember that this is going to be the multiplier. That's going to tell us where to move the points at the end. Okay. So now, from 1 to 5, how comfortable are you with this? 4, 5, 4, 5. Okay. All right. However, what if I gave you something like this? And by the way, send me your notes. Example number 5. Transform the parent function f of x equals 1 over x given g of x equals 3x minus 4 over x minus 1. So copy that. Make a little coordinate plane. I'll wait for you guys. Make sure it's nice and neat. Go. All right, for the sake of time, let's graph the parent function together. Our VA, we know it's x equals 0. And our HA, we know it's also 0. So at 0, and 0. However, then 1 to the left, 1 down, 1 to the right, 1 up. All right, there's our parent function f of x. All right, what do you notice on this one, Enrique? He said it doesn't have a 1 on the numerator, right? Now we have that. What do we need to do to rewrite this? Tell your neighbor, remind your neighbor, what do we need to do? What is it? Very good. You divide 3x minus 4 divided by x minus 1. So, what number times x gives us 3x? 3. So 3 times x is 3x. 3 times negative 1 is negative 3. We're going to subtract. And what do we do when we subtract? We distribute that one here and here. So these cancel. That leaves us with negative 1 as a remainder. So let's rewrite that. Our answer is 3 plus negative 1 as the remainder over x minus 1. However, we need to send this where, everyone? Yeah, right over here. So that's plus 3. And where do we send this negative to? To the front, is that correct? So we end up with negative in the front, a 1 on the numerator, and x minus 1. And all that equal to g of x. So now that we have this, tell your neighbor we're going to move all of this to according to that. Where are we going to move it to? All right, where to? You, Lisa. 1 to the right and 3 up. That is correct. So from the center, I'm going to go 1 to the right, 3 up. So my new asymptote is here and here. My original point, look up, it would be 1 to the left, 1 down, 1 to the right, 1 up. However, look up, guys. What is this? Flip it, right? So instead of being 1 to the left, 1 down, it's 1 to the right, 1 to the left, 1 up, and 1 to the right, 1 down. So my new graph is here and there. All right, some of your notes, please. Were these kind that you need to first do the long division? How comfortable are you with these from 1 to 5? 5, 5, 4, 5, 4. Yeah, we got this, right? We did plenty of practice last week on these. All right? So, there's a code for the home plate for tonight. Once again, PGFB5, PGFB5. And the home plate is going to look something like this. It's only 6 of them. I gave you 3 that are already, in the rational form, and the other ones where you need to do the long division. All right, we'll stop right there. Once again, make sure you put the you turn in your notes. Also, make sure you go to Canvas, go to grades, take a screenshot, bring me that sign tomorrow. Pretty please. So like that, your parents can take you to get a Happy Meal or something. All right, we'll stop right there. Those of you following on YouTube, make sure you put in some practice. See you guys next time. Peace.